Hi everyone! This is a tutorial playlist of videos of the Dornheim Segmenter program, which is a software used for the conversion of cities and MRIs to 3D models, so that they can be used for other purposes such as 3D printing or any other. Well, let's start by downloading the program from its website, dornheimsegmenter.com, or from Google. The version we want to download is the Dornheim Segmenter Modeler. It is a payment program, but you can access a free trial of 15 days. With the program already installed, we will see that it is organized in three parts. In the middle, we have the window where all the magic happens. On the left, we can see how our project is organized. For example, here we would see our dataset, here below we will see the segmentations that we are creating, and here the 3D models that we will be getting as we go forward. On the right, we have basically all the tools that we will use for each of the categories on the left. That is, tools that can be applied to the dataset, tools for our segmentations, and tools to apply on 3D models. Let's start importing a dataset, for instance, an abdominal CT scan. We click on Project, DICOM Collection, we select the folder, and that's it. We already have the images ready to be converted to 3D models. In the bottom of the window, we have the navigation hotkeys. Left click to move forward or backward, right click to modify the contrast, Ctrl right click to modify the zoom, and Ctrl left click to pan the image, and so on. You have them all here. It is also interesting that we know the different possible display windows that we have. This way, for example, is a complete window for the image, or a complete window for 3D model, or a combination of MPR and 3D window, and that's the way that suits us best. I personally prefer simply the full window of the axial plane. Now let's start with the segmentations, and we will use the easiest and most commonly used tool, the threshold. To do this, we go to the segmentation tools on the right and select the threshold tool. We can see that a distribution appears, a histogram. This is very simple, relax. This is simply a representation of the intensity of the pixels. For example, we see that the vast majority of pixel values are close to black, while there are very few that are really close to the white value. If we move the selector to the right, what we are doing is labeling all the pixels that are above this value, and we are discarding those that are below. Let's make a 3D model of the bone structures. The CT is the modality of choice for this task. We select the desired threshold and accept. Now we see that we have a new segmentation in this column, and we can export it in different formats or turn it into a 3D model, which is our real objective. We wait for the conversion task to finish, and that's it. This is the 3D model that we obtained from our first segmentation using the threshold tool. As we can see, the model is quite accurate according to the CT data. Although having applied only one tool, we will also notice that we find certain imperfections like these holes or these floating objects that correspond to the table. We will also notice that certain unwanted structures have been included in the segmentation because they met the threshold criteria that we applied. To obtain more accurate models with fewer errors, we will need to apply other tools besides the threshold or even combinations of them, as we will see in the following videos. Another structure that we can easily obtain through the threshold tool is the surface of the skin. We will apply the threshold, but this time with a different value. As we can see here, we accept the segmentation, then we press the button to convert it to 3D model, and we already have the model. Again, as we see, we have some floating objects, and inside the model we will have holes and imperfections. We will see how to eliminate them in later videos. So this is the end for the video number 1 of this tutorial.